All right. Hello, everybody. It's time for us to finish off chapter 4. And there'll be a lot more of the use of Excel. So I'm going to suggest that you guys get the toolkit that the authors, the publisher has given us to use to help look at all of the calculations that we're doing. In addition to that, hopefully you guys have taken my advice and started your own spreadsheet that you're going to use to make sure that you know how to do each of the calculations and with all the various formulas in Excel. So I just need to get us where we were. We ended on the last video. And so it's going to be in the chapter, there it is, 4-11, finding annuity payments, periods, and interest rates. Okay, so, all right, so we have the 5 variables. We have the number of payments, we have the interest, we have the payment itself, we can have future value, we can have the present value. If we know any of the 4, we can create the 5th. Also understanding that if we have type in there, 0 means that we have an ordinary annuity and 1 means that we have an annuity due. And remember, an annuity due means the payment is made at the beginning of the first period. So on our timeline, that would be at 0. An ordinary annuity means that the payment is made at the end of period 1. All right, so there's a discussion in your book on pages 163 in this section of 14-11 where it talks about variable annuities. And this is where if you look at how annuities are supposed to be run, they are supposed to take your money and invest it in government securities so that it's super secure and that it will have a guaranteed rate of return. Hartford, which is a large old insurance company that deals a lot in annuities, decided to create something called a variable annuity, in which they were investing not in government securities, but in the stock market, which gave them the ability for a period of time to offer returns in excess of their competitors, which was a very good move for them for a while. So we got to the Great Recession in mid-2000s. And all of a sudden, their investments were starting to lose money. They were guaranteeing particular returns on their variable annuities. And as a result, they were very close to going into bankruptcy. They were only saved by the government bailing them out. So you can read that if you like. It's interesting. We'll talk about a lot of that when we do the Big Short. But let's just continue on where we are. Finding annuity payments 4-11A. So if we have all of the other information and what we're looking to do is to find the payment amount for an annuity. So the problem, we need to accumulate $10,000 and have it available 5 years from now. We'll earn 6% on our money. So we know future value is 10,000, present value is currently 0. Number of periods is 5, and the interest is 6. Let me see if I can share my spreadsheet. Okay, bringing it up. So I just have to find where I am in here. Great, finding number of periods. Payment amount of an ordinary annuity. Okay, so that's what we are right here, finding the payment amount of an ordinary annuity. All right, so over here we have it. I always like to set up my little chart here. So the rate 6%, number of periods 5. Our future value is $10,000. So what we're doing is basically all we're going to do is we're going to get this out of my way. Put back. Hit the insert function, a button, and I'm looking for payment. Okay, so I'm going to have to go back into financial. EMT right here. So rate is going to be there. Number of periods is going to be there. And future value is right there. And if I hit this, nope, something went wrong. Let's see. What did I do wrong? I didn't hit the number of periods properly. Okay, now doing that. That's not right. Let's see if I set this to 10, my negative. Let's see. I did it earlier before, right? So B75 is the rates. B76 is the number of periods. B78 is 0. B79 is the future value, so that should have worked. Okay, I guess I have to put the present value in there as this. Make that work? Nope. The correct one is payment. 75, 76, 78, and 79. So it should have worked. Rate is 6. Number of periods is 76. Present value is 78. 79. So it should work. It's not working. I don't know why. Huh. Let's hit delete. Let's look at this again. All right. So the rate is 6%. The number of periods is 5. Present value is 78, which is going to be nothing. Future value is B79 of 10,000. If we hit OK, gives us the 177396, which is what the book is saying that we should be getting here. That's again, let's do this one here. Rate. Number of periods, 5. Value, 0. Future value, 10,000. Okay. There it is. I don't know why the other one didn't come out right, but 1,773.96 is the amount of payments that would be necessary to be made over a 5-year period with a 6% return to get you to $10,000. Okay. So continuing along, and this is at the end of the year. If you want to do it as an annuity due, that means you make the payment at the beginning of the year. Obviously, you would think that the amount would be smaller because you're going to have an extra period where it's going to earn the interest. This is basically also anything you would expect. Payment. The rate is going to be that. The number of periods is 5. Present value is 0. Future value is 10,000, and type 1 because it's an annuity due. Now this one I decided to put the numbers themselves in as opposed to using the cells, just to prove that you could make this work with just using the numbers as opposed to using the cells. So you'll have your choices. All right, so moving along, finding the number of periods. So same thing, I have our chart over here. Rate is 6%. We know that the payments, let's see, so suppose you decide to make end of year payments. You can save only $1,200 per year, assuming you would earn 6%. How long will it take you to get $10,000 So we know we have 6%. We have $1,200 payments. That's a negative number. Future value is going to be $10,000. So if we hit this here, so our number of periods is the function that we're using. So the rate is going to be B93, payment is B95, present value, we have nothing there, future value is B97, the type is 1. Going to be 6.95, something, something, something. The book says 6.96 period, so basically 7 years that you would have to make these payments. If it's going to be a annuity due, looking at that, I also inserted the type as being type 1 here from B98. So that changed it from 6.958 to 6.631 periods. So a little over 6.5 and a little under 7 are the two answers here. All right. Next page, finding the interest rate. So you save $1,200 annually, you still need to get to $10,000 in 5 years. What rate of return would you have to reach your goal? So this is just going to be using the function for finding interest, or rate, excuse me, rate. So then once again, number of periods, we have that. Payments, we have that. Future value, we know we need to get to 100. So if this is an ordinary annuity, we don't have anything under type. We leave it there. We find that it's about 26%. Now I have this rounding to 2 places. The book goes 25.78. We can change that if we just want to change the cell, but we'll just leave it at 26 for right now. If it's an annuity due, then that means we make the payment at the beginning of the first period instead of at the end of the first period. So going to function here, we're once again going to have the number of periods, the payment is negative 1,200, future value of 10,000, but now we have the 1 in there as the type because it's annuity due and annuity due. So we end up with 18%. The book comes up with it didn't even do it. I did it myself. So anyhow, we can see that it makes a big difference. Now, where are you going to find 26% return? Not anywhere in the legitimate markets. Where are you going to find 18%? Not anywhere in the legitimate markets. So realistically, you're telling yourself that this is going to be a speculative type thing. So you don't want to be doing a whole lot of that. All right, at the end of this section, there was a self-test, what I thought it would be interesting to go through, and I just have them all sitting over here. You inherited $100,000, invested it at 7%. How large of a withdrawal could you make at the end of each of the next 10 years and end up with 0? So this is an annuity, regular annuity, okay? So if we just go here, I just shoved the numbers in as opposed to setting up the chart this time. Because it's a self-test, I didn't want to devote a whole lot of time to it. So 7% return, 10 years, $100,000 that we need to get. No other number is necessary. So we would need to make payments of $14,237.75. That agrees with the book. Annuity due, everything's going to be the same, of course, except we're going to have that 1 in type because the payment is going to be made at the beginning of the period. So it changes our payments to $13,306.31. Question number 2. If you have $100,000 invested at 7%, want to withdraw $10,000 at the end of each year, how long will your funds last? So now what we're looking for is the number of periods. Okay. So if we go to our number of period function, and I put in the 7%, I put in the $10,000. That's what we're going to be withdrawing, negative $10,000. The present value is $100,000. Click OK. We can have 17.79 periods, almost 18 years. The question then asks, how long would it last if you earned 0%? Well, if you don't have anything compounding in there, $100,000 and you take $10,000 out each year, it'll last 10 years. That's just 10,000 divided by, 100,000 divided by 10,000. What if you earned 7%, but limited your withdrawals to $7,000 per year? Well, you would be able to go on forever because you are getting $7,000 in interest every year on your $100,000 at 7%. You would never reduce the principal at all. Principal would stay at $10,000. So you would be able to go on forever. Your uncle named you as a beneficiary of the life insurance policy. The insurance company gives you a choice of $10,000 today or a 12-year annuity at $12,000 at the end of each year. What rate of return is the insurance company offering? Okay, so what I did was I did rate. Okay, so I have okay, number of periods is 12 because it's going to be a 12-year thing. They're going to give us $12,000 each year. I put in negative $12,000. The current or present value is $100,000. So to come up with a rate, it says 6%. In the book was 6.11. Once again, this is a rounding thing. I could change this to make it work. I'm just too lazy to do that. I'm sure that we're correct here. And finally, you inherited an annuity that will pay you $10,000 a year for 10 years, and you receive the first payment today. It sounds kind of like a annuity due, right? A professional investor offers to give you $60,000 for the annuity. If you sell it to him, what rate of return will he earn on the investment? Okay, so we're looking for the rate here. So 10 years, $10,000 put in as a negative number. Him offering us $60,000 makes this a present value of $60,000. And since it's an annuity due, we put a 1 in type, and we end up with 14%. 13.7 is what the book said. So once again, I know that's right. It's just a rounding issue. If you believe that a fair rate of return would be 6%, not 13%, how much should you get paid? You're going to tell them you need $78,000 or you're not selling. Okay, so if you went through and redid all of this and put in a rate at 6%, then we would come up with a new value. So instead of doing rate, we were doing present value, I believe. Yep, just present value. Okay. All right, so that takes care of that section. Moving right along. 4-12, uneven or irregular cash flows. Now, this is where we're now moving away from the annuity. Okay, an annuity gave us a regular payment for a specific period of time. $10,000 a year for 12 years. That's an annuity. Okay, it's the same number for a very specific number of periods. All right, now we're going to talk about what happens if we have a situation where the amount that is being paid is not the same every period. Okay, and in the business world, this is something that's going to happen. You're not, you may have the choice to invest in a machine, but the return you're going to get in increased profit over the next X number of years may not be equal. It may change. It may start low, go large, then go low again, and then finally run out. So how do you value that? Okay, so the first choice is that we have something that resembles a bond, where it pays us a certain amount every period, and then at the end of the number of periods, we get a lump sum where we get the bond amount back. let me change what I'm showing you for a second here. I'll put you on the timeline that they're giving us in the book, which is this here. Annuity plus an additional final payment. So we had $100, $100, $100, $100, and we got our final $100 in the 5th year, but we got our $1,000 back at the end of that period of time. Then that would be in a nature of a bond. Okay. Irregular cash flows. This is a business decision. Let's say we have an interest rate of 12% again. You start with 0 at period 0, then we end up with 100 at period 1, then 300, then 300, then 300, then 500. So then what we can do is we can calculate the value of these cash flows and compare that to what our investment would need to be to make that happen. Okay, so annuity plus additional final payment. The problem they're going to give us is a 5-year 12% ordinary annuity plus a final payment of $1,000. I did that different. What am I doing here? I think I just changed the numbers because I was using it for some other purpose. Oh, here we are, the bond valuation. All right, so what we need to do here is we need to use function present value. Okay, so present value is going to be, in this case, I put the figures in myself. Rate of, and I'll just do it the right way this time. I was using this for other purposes. Let's do here. I'm looking for present value. Rate, 12%. Number of periods, 5. Payment is, consider stream 1, notice that a 5-year 12% ordinary annuity is a final payment of $1,000. Okay, but it's only paying $100 right now. So $100. Oops, payment. Periods 5. Payment 100. That should be a negative number. I'm doing this wrong. This is future value. I don't want future. I want net, present value. Too small. I couldn't read it. Okay, rate 12%. Number of periods 5. Payment 100. The future value means that we're going to get that $1,000 at the end of period 5. Okay, and this is a annuity, regular annuity, or bond, so it looks like a lot like a regular annuity. So it shows the 927.90. If we'd have made this a negative number, like it should have been. Oh, it doesn't like that, does it? I bet you this has to be a negative number too. 927.90. Okay, and that's the value of the bond. The interesting thing is we know that it's a $1,000 bond, and we know that it's 12%. So if well, it's not 12%. The rate in the economy is 12%. If this bond were paying 12%, then the interest would have been 120. So because of the fact that we weren't getting the proper amount of interest, this value, next chapter 5, we'll see that this bond had to be valued below face value. All right, so let's move on to what happens if we have unequal amounts. So the cash flows are irregular. Okay, I'm going to show you the book. I guess I could have also showed you the author's spreadsheet. But what we have here is we have an interest rate of 12%, and we have periods 0, 1, 2, 3, 4, 5, and we show the cash flows that we're going to be getting in each of those. So nothing in period 1 or 0. Period 1, we get 100, then 300, then 300, then 300, then 500. And here's your step-by-step process. We could catch the present value of each and every one of these and then add them together. You could use your financial calculator, or you could do the Excel spreadsheet, which guess what I'm going to suggest we do? That's right, the Excel spreadsheet. So going back to my spreadsheet. Okay, so now what we have is I've created a table. Okay, so period 0 through 5. Cash flows in each of those periods, 0, 100, 300, 300, 300, 500. The rate is 12%. Okay, so now if I look at my function, what am I looking for? I'm looking for something called net present value. Okay, I can't use just regular present value now. I have to use net present value because of the fact that this is now unequal sums. All right. So if this was an equal thing, I could have just equal payments. I could have just used the calculation to come up with the value of an annuity. But since we have different cash flows, it's wrong. It's different. Okay. So the NPV, net present value. So rate is 12%. Value 1 is 100. Value 2 is 200. Value 3 is 300. Value 4 is 300. I have to slide down one more because I have value 5 here, which is going to be the 500. I've just used the cells there. Okay. So what you do is you input each of the cash flows and you put in your percentage, your discount rate or your compound rate, whichever you wish to call it. And you see that the Excel will calculate it out. And they're saying that this cash flow present value is $1,016.35, which is exactly what the book says it should be. So how much money is actually on the table? 5, let's see, 9, 14, 1,500 is the amount that you're actually receiving. We're saying the present value of that is 1,016. One of the things that works against your valuation here is that the big money is further out. Notice in year 1, which is going to have the smallest discount rate, it's only $100. The big money is out here at year 5, where you have $500, but the discount rate is going to be massive. Okay, so that's how you do it. Okay, once again, that function was net present value, NPV. All right. Self-test. I did all the things for the self-test again. Okay. What is the present value of a 5-year ordinary annuity of $100 plus an additional $500 at the end of year 5 if the interest rate is 6%? Okay. So self-test, this is an annuity because it's making the same payment each of the periods of $100. We just have a future value that we have to take into account. So 6% is what we were told. Pay 5 years, payments of $100 per year, right? Ordinary annuity, by the way, and the present a future value, the $500 when we get it in the end. So it's a negative number. Actually, it's this here. So it's going to be B131. Rate is this one here. Payment is this one here. The future value is this one here. You click, let it do the calculation, $1,015.21. Exactly what the present value be if the $100 payment occurred in years 1 through 10. Oh, okay. 5-year annuity. All right, I'm sorry. The first question is the 5-year annuity, which is this one here. Okay, the answer is $794.87. If it was a 10-year and it was an ordinary annuity in 5 years at the end, 500 at the end, it would be this, the 1,015. So I'm sorry, I had done two of them. I had done the 5-year one and I did the 10-year one, 5-year and 10-year. All right, uneven. What is the present value of the following uneven cash flow stream? 0 at time 0, 100 at year 1, 200 at year 2, 0 at year 3, and then 400 at the end of year 4. So I made my chart here. There's nothing here in 0, so 100, then 200, and then we remember it said 0 for period 3, and then period 4. The rate of interest is 8%. Let's find out the present value of this flow. It's going to be what the net present value, right? So that should be the function we use, NPV. The rate is there. Value 1, 2, 3, and 4. So C139, D139, E139, and F139. Calculate it out, 558.07. Exactly what the book says that it should be. So once again, $400, $500, $600, $700 worth of cash flows, but we had to discount them back. Okay, we needed the present value of these future numbers. So at this particular rate, this cash flow is worth $558. Okay, 413, future value of an uneven cash flow. So now we're going to talk about future values. Let's share the book at this point. All right. Future value of an uneven cash flow is found by compounding each payment to the end of the stream and then summing the future values. Okay, so we end up here with the step-by-step, the 100, 300, 300, 300, 500. So the future value of this $100, so you're compounding going forward, the future value of this 300, of this 300, of this 300, this 500, its future value is 500 because it's at the very end of the period, right at the valuation date. So if you add together all of these payments, the future value is 1791.15. Here's your calculator version. Here is your Excel spreadsheet. It's going to take 2 steps. First, we have to find the net present value, and then we have to put it into the future. Okay, so there's no one step here. We have to go backward in time and then go forward in time. All right, so going back to my spreadsheet. That's this example here. So period 0, 1, 2, 3, 4, 5, nothing in period 1, then 100, 300, 300, 300, 500. The rate is 12%. First thing I did was I found our net present value. So I used the NPV function and I put in my variables. There's my rate, and then I have my cash flow, 1, 2, 3, 4, 5 of them. If you see, I have to go down 1 to get to value 5. And then I hit OK, and I come up with the net present value of these cash flows. But I wasn't asked for the net present value. I was asked for the future value. So now what I have to do is I have to take this and compound it into the future. So it's going to be just future value, FV. The rate is going to be the same, the 12%. The number of periods is going to be 5. I just grabbed the top number here. And then I put in the present value, and I just used this cell here. It equals, function, compute, 1,791.15, exactly what the book says we should do. So this is, unfortunately, I guess the financial calculator could do this in 1 step, but we here on Excel needed to do it in 2 steps. First, we had to find the net present value, and then we had to calculate the future value. Okay, self-test at the bottom of this. What's the future value of cash flow stream 100 at the end of year 1, 150 at year 2, and 300 at year 3? We have a 15% return. And what do we want to know? what is the future value of this? So, unfortunately, once again, we just did that here. We're going to have to do the net present value first. Okay, so we use NPV, put in all of the appropriate boxes, 15% rate, the three cash flows. We hit OK, and it gives us a current present value of 397. Then we just use the FV function. The rate is still 15%. Number of periods is 3 this time, right there. And the present value is what we calculated before, the net present value. So when we take that into future, $604.75, exactly what the book says we should be getting. Okay. Solving for interest with irregular cash flows. So what is our interest factor? This is going to be the internal rate of return. Okay, so basically we've been using the term rate up till this point, but now because we're going to be using unequal or irregular cash flows, we're now going to be looking for the internal rate of return, the IRR. Okay. All right, let's see what the problem here is. You have an annuity plus financial final lump sum. You can input values. Okay, so that the first thing that's in the book here is the calculation of the bond value. Irregular cash flow with a calculator is more complicated. Always use factor. Same answer using Excel's IRR function as shown in figure 4.9. Notice when using the IRR, unlike the NPV function, you must include all cash flows, including the times zero cash flow. Okay, so remember we had to, in this example, in this problem, we had to invest $1,000, okay? We invested $1,000. We have 12.55% at the rate. I know that's the answer we're going to get. Okay, in the old days, if you don't have the financial calculator or you don't have the spreadsheet abilities, then what you would do is you would do a lot of guesswork. And so you would end up coming up with a rate of return, and then you would go to a number either higher or lower, and then you would start moving inward to try and find the right thing. So you're doing the calculation over and over and over, and it can get very time consuming. So what do? What do we do? We do the internal rate of return. So you're looking at my spreadsheet right now. We have $1,000 investment. We have $100 in year one, 300 in year two, 303, 304, and 505. So now for an internal rate of return, we have to include everything. So our year zero at the beginning of the process, we had to invest $1,000. Okay, so clicking on this and looking at, there's not much to put in here. It's just internal rate of return. Now, it doesn't look like you've got a whole lot going on here. It's just a whole bunch of numbers. Yes, that's right, but it includes what we paid in 0.0. So now the spreadsheet knows that it includes our investment, and then it knows the rest of the numbers are our return. So now all this is values B161, right there, the investment, through G161, which is our last return of $500. So basically, it's just those two cells and a colon between them. That tells Excel that we want it to use that entire spread of cells. So when we hit equal, we end up with the internal rate of return of 12.55%. Okay. If you want to see how that actually works, I'll do it again right here. IRR, hit OK. The values, I'm just going to click on here. Then I'm going to hit the colon, and then I'm going to hit period 5, hit equal. Okay, now this is coming up to 13 because I didn't bother changing it. I think I will see if I can make this happen. Here we go. Pull this down out of my way. I'm sure hoping this is. Go back to my, just had to check, see where we were. Okay, so using this, if I just were to go to move, okay, here we go. Here, just to prove how you get rid of that 13%, bring it to what it should be, I'm just going to move the decimal point to change the rounding. See, so calculation, it rounded to 13, but the answer was actually 12.55. All right, so let me move this stuff around again. Gotta get back to here. Put that up there. All right, so so the internal rate of return for this particular cash flow and investment was 12.55%. Really isn't that bad. Self-test. Investment costs $465, period 0, negative 465. Expected to produce cash flows of 100 at each of the next 4 years, 1, 2, 3, 4, plus another lump sum payment of $200 in that 4th year. So we have 100 plus 200 here. That's why this says 300. Hit the internal rate of return. Basically, all I'm doing here is saying that I want the computer to look at B168 through F168. It equal 9.05, exactly what the book says this should be. Another question, investment cost $465, there it is. Expected to produce cash flows of $100 at the end of 1, 200 at 2, and 300 at 3. So what is the internal rate of return? Same thing, we're just going to have use the IRR function and use all of these cells, 11.71, which is exactly what the book says we should have gotten. All right, so that's a lot of way of calculating cash flows. If it's cash flow is equal for a specific number of periods, then we can just use the annuity rules. If it is an irregular cash flow, then we have to use other methods. Okay, so if we're looking for a present value, we can use the present value method, if the NPR method. If we're looking for a future value, then we've got to first calculate the NPR and then take it into the future using the future value method. And now what happens if we just want to come up with the internal rate of return on something, then we use the IRR function and we just put in all of the payments, what we paid for the investment first as a negative number, and then all of our returns. And the IRR function will do calculate the return of investment for us. All right, so now let's talk about getting back to what happens with compounding or discounting. One of the problems that we have is that in the world, everything's not done on an annual basis. All right, I'm going to go back to the book now, so I have the book going on here. Share the book. Okay, so semi-annual and other compounding periods. So up till now, we've been using the yearly period as the compounding. The only problem is that what happens if you are going to have let's say you put money in the bank, you put $1,000 in the bank, and instead of them compounding your interest annually, they compound your interest semi-annually. They do it twice a year. Is that to your advantage? Well, yes, it is, because remember, because of compounding of the interest, you're getting interest on your interest. So instead of just getting one period of interest between, the date you put it in and 1 year in the future, there's that point in the middle at 6 months where you get interest, and then at the 12-month period, you get interest on your interest. So you're going to get a bigger return. All right, so this is semi-annual compounding. With semi-annual compounding, you will receive, okay, so if you put $1,000 in the bank at 6% interest, and they are going to give you semi-annual compounding, that means at 6 months, you get $30 worth of interest. At 12 months, the interest is going to be calculated on the 1,030, not just the 1,000, okay? Now, in order to do this, we have to make some adjustments to how we're looking and using our tools, because our tools don't care what period we use, but we have to input the right information, okay? So we're going to talk about different types of interest here. Can't remember if I'm on the book or not, so I'm going to go back. Yes, I thought I was on the book, but I'll just do it again. All right, so types of interest. Nominal or quoted rate. The nominal annual interest rate, or just the nominal rate, is the rate quoted by banks, brokers, and other financial institutions. You talk to your banker, their nominal rate is the one they're going to give you. However, it's not very meaningful. In order for it to be meaningful, we have to look at what we're doing as far as the way we compound it, okay? So example, a branch might give you a CD at 6% compounded daily, where a credit union might give you a 6.1 per compounded monthly. You'd have to actually see what the effective rate of this would be. Periodic rate. The periodic rate is the rate charged by a lender or paid by a borrower per the period, okay? It can be a rate per year, for 6 months, per quarter, per month, per day, or any other time interval that you want to use, okay? For example, a bank might charge 1.5% per month on its credit card loans, or a finance company might charge 3% per quarter on installment loans. So this is a periodic rate. What is the interest rate for the period? Okay, so up above, we had a 6% nominal rate. But if it was going to be compounded semi-annually, then we're going to end up with the period is going to be the 6 months, okay? Because that's how often it's going to compound. So we're going to compound every 6 months. But what's the effective interest rate for that 6-month period? It's not the 6%. That's for the year. So it's going to be 3% for 6 months. Okay, so that is our periodic rate. We have to understand that. Okay, so over here they say 1.5% per month. Okay, so if you were to extend that out for the year, that's 18% nominal rate. Okay, so 12 months times 1.5. Or if you have somebody that's charging 3% per quarter, that's 1% per month. That's going to be 12% per year nominal rate. But those things are not necessarily useful to us, okay? What happens is you have to remember that you're going to have a certain number of periods. So to illustrate, suppose you invest $100 in an account that pays a nominal rate of 12% compounded quarterly, or 3% per period. How much would you have after 2 years if you leave the funds on deposit? Okay, so here you go. Since you have 4 periods in the year, and we're listing it at 12% per year, you have to divide the 12% by the 4 periods. We'll come up with 3%. So that's how you get the 3% rate here, which is your periodic rate. But now, over that 2-year period, we now have 8 periods. Okay, so over the 2 years, we're going to have 8 quarters. 1, 2, 3, 4. There's the end of the first year. 1, 2, 3, 4. There's the end of the second period. So we have to make these adjustments when we have compounding that's going to be happening anything other than annual. Okay. Here's a formula for you. Feel free to use it. Here's how you use your calculator. Effective or equivalent annual rate. The effective rate is what we're going to call it in Excel. Okay, so the Excel function is the effective rate, which would be the nominal rate, and then we also have to put in the number of months. Okay, so all right, to calculate the effective annual rate, all right, I had to sneak away there for a minute just to make sure that I knew what I was doing. So let's talk about the effective rate real quick here. And the problem they give us in the book is if you have an account which is going to charge you 1% per month, that would be 12%, right? The nominal rate of 12%. Or what if you had somebody that was charging you 3% per quarter, which would also be 12% nominal rate, right? But excuse me, they have different effective rates. So first off, let's look at an effective rate here. And all I did was I put the actual numbers in. So the nominal rate is 12%, 0.12. And if this is monthly, it was 12 periods for it. So then you put it out, it becomes 12.682503. What about that one that was done on a quarterly basis? Still 12%, 0.12. The number of periods for the effective rate is 4. So that gives us 12.55081. If you take a look at the difference between those two, there is a difference. The numbers are out there in the distant decimalization, but there is an actual difference. So this one is going to be much higher because it is compounded monthly. This one is compounded quarterly. So because this is going to have much more compounding of interest, it's going to be higher. Okay, so we'll move past that. Let's go back to the book for a minute. All right, so that's this stuff right here that we just talked about. Then the next thing is the annual percentage rate. The annual percentage rate is the nominal annual interest rate actually charged on loans. Okay, the APR is especially important for loans that use add-on interest, which calculates the total interest to be paid by multiplying the amount borrowed by the quoted rate, dividing this product by the number of times per year that a payment is due, and requiring the first payment due at the time the loan is made. For example, suppose you buy a refrigerator, a stove, and a dishwasher for $3,000. The store offers you financing 1 year and an add-on quoted rate of 8%. The total interest then is $240, which is very simple. $3,000 times the 8% gives you $240. This total interest charge is added to the cost of the kitchen appliances, bringing us to $3,240. So it's that plus that. Then divide that total by 12 to get your monthly payments of $270 per month, with the first month payment made at the time of purchase. So this is acting like an annuity due. Okay, we have to make the first payment at period 0. Okay, keep that in mind. There's a huge difference in how these things work out. depending on when the first payment is made. So if the first payment is made at period 1, it's an annuity. If it's made at period 0, it's treated like an annuity due. Okay. So therefore, are you actually paying 8% on this loan? To find the APR, set your calculator. And one of the reasons that this has become an important thing is because the truth in lending laws are requiring lenders to actually put out there what the APR is, the annual percentage rate. Because now it requires us to go through this calculation as to what your actual internal rate of return, if you will, on that loan is. All right, so effective annual rate, let's see what they're going to give us here. Give me a second here. All right, so I'm going to show you the way that I did this to create the annual percentage rate. So using my little wonderful chart that I've been using, I set up the nominal rate at 8%, and then I set up the periods 0 through 12, and then I showed the cash that happened. Okay, so now remember, we borrowed $3,000. However, we were required to make the first payment of $270 at the same time. So we really only got $2,730. And that's a positive number because it came to us. Okay, so now we take that, and then each of the next 11 months, we make the remaining 12 payments of $270. And those are negative numbers because we're making the payments. All right, so now what we're going to do is we're going to first calculate the internal rate of return. And that's basically the IRR function with all of these cash flows. All I did here, it's B194 through B205, and we end up with an internal rate of return of 1.4313%. Okay. Now, in order to come up with our APR, we just multiply that times 12. Okay, so this number here is times 12, and I don't know why I know why, because it's sitting up there as a percentage and it says percent, so it's using it. I had to multiply it by 100 to get the percentage properly. So, or if I guess if I would have set this to a, get rid of the 100, and just set this to percentage. That's why. Okay, so it ends up that my actual APR is 17.18%. Ridiculous the way that they made this happen. You know, the other thing is that it would be 8% if we didn't have to make a payment until here, but we're actually making payments right along, including one on day 1. So one thing that I remember from the undergrad here is that when you're making payments against a loan like this, the effective rate or the APR is actually going to be almost double what your nominal rate is. So 18% or 8%, and we're ending up with an actual 17%. I guess it went above double because we made the payment at 0 as opposed to 1. The effective rate is calculated as paren 1 plus the internal rate of return, close paren, and then to the power of the number of payments. So the number of payments is 11 minus 1. So 1 plus C193. There's our IRR. The caret gives us to the power of A206, 12 periods, and then the minus 1. that gives us, it comes out 0.18 because I just need to set that as a, so that it's sitting in a percent. So format the cell, percent, about 18.59%, which is the actual effective rate. So a lot of games being played here. They were telling you it was an 8% return. They're making you make payments against it. So this actually becomes an extraordinarily large percentage that you would be paying in order to make this happen. So this is an important way to do this, to look through and find the effective rates to see what we're actually paying. Okay, moving right along. All right, the result of frequent compounding. So because interest is going to be earned more often, you should expect higher future values the more frequently that you compound your interest. Notice that, so if you look here, they've given us a chart. If we take 12% and we do it on an annual basis, then our effective rate is going to be 12%. If we do it over 2 periods, our compounding is going to take that to 12.36, quarterly 12.55, monthly 12.6, daily 12.7. The increase going from annual to semi-annual is 0.32%. Going from semi to quarterly is 0.17. So it's one of the things that the book wants to point out here is that the biggest jump is right here, going from annual to semi-annual. Stop sharing for a second. All right, so just looking at the self-test things at the end of this section of the chapter, there's questions that talk about compounding, and they do make a little bit of sense. Would you rather invest in an account that pays a 7% nominal rate with annual compounding or with monthly compounding? Well, annual. And I actually did this in the here on my little spreadsheet thingy. If you have 7% rate right here, and you have a period, say if this is daily compounding and this is monthly compounding, daily compounding will get you 7.25. Monthly will get you 7.229 or 7.23. So there is a difference, okay? So understand that. What's the future value of $100 after 3 years if the appropriate interest rate is 8% compounded annually? So it's going to be 125.97 compounded monthly, 127.02, but goes up. Present value of $100 in 3 years, appropriate interest rate is 8% compounded annually. Present value from 3 years in the future, compounded annually 78.39, compounded monthly 78.73. So there are differences. How it's compounded does make a difference. So I'm just going to move forward here. Fractional time period. So what happens if we're talking about portions of a period? So far, we've assumed the things that happened at the beginning and the end of the periods that we're using to measure. But the reality of it is that sometimes you don't wait until the end of the period. For example, suppose you deposited $100 in the bank that pays a nominal rate of 10%, compounded daily based on the 365-day year. How much would you have after 9 months? So the answer here is 107.79. And let me show you the book to show you how they calculated this. Okay, so they took the periodic rate of 10%, divided it by 365, and came up with a interest rate per day, 0.000273973. And this is, this is how we do it. When I have to do allocations of things in real estate transactions, I will do per day rates on things, and that is a legitimate per day rate. Notice we have to go out a whole lot of decimal points to make it valid. Number of days, so they're going to do 9/12 of 365-day year. So the 0.75 of 365-day year, 273.75 days. They're rounding to 274. So multiply the $100 times 1 point, and here's your daily rate, and then it's up to the 274th power because of the fact that we're compounding. Okay, so that's not just this times 274. So that's a higher number. So that's 10779. And going to my spreadsheet. I did it right here, transactional fractional time periods, compound 10% compounded daily. Functions. So when I hit the insert function, you can see that I used effective. Did I use anything? What did I use here? No, I did the actual formula that they did. No, I did 100 times to make a, here's the, oh, it's $100. Here's the 1.0, and then the interest rate caret 274 to bring it to the 274th power. So it did come out 107.79, and that's the number that the book gave us also. All right, so all right, so now what we're going to do is we're going to talk about amortizations of loans. Now, amortization is something that we really haven't talked about in this class because we've been working on trying to come up with valuations by compounding our interest or by discounting by the interest rates. And so now we're going to talk about installment loans or amortizing loans. Installment loans, another thing that it would be called. And basically what that means is that you borrow the money and then we have to calculate out what your payment is going to be every month so that you will end up with equal payments over the period of the loan so that you are paying both principal and interest the whole time that we're moving forward in time, so that when you get to the last payment, that the actual spread, and the spread between principal and interest changes with each payment, because the principal amount changes, so the interest amount will change, so the principal amount will change, because the payment amount doesn't change. But when you get to the final payment, that the spread of interest and principal will actually take the principal down to zero, okay? So we're going to calculate out what those payments need to be, and then we're also going to calculate out what the, we're going to calculate out the amortization tables to show how that works, okay? So the different types of loans that we're talking about would be automobile loans, mortgage loans, student loans, and other business loans. Okay, so amortization is a good thing because what we want to end up doing is getting things paid off. Not everybody's going to be able to do lump sum things. We do know that in business world that there's a lot of loans that are out there that all you do is pay the interest and then you refinance or you have a balloon payment at the end. But for the rest of us, we need to make our payments on a relatively even basis. So we calculate out what that payment needs to be to pay both principal and interest for a reducing balance as we move forward. There's an interesting thing in the book. I'm going to share it with you. It makes a discussion of payday loans, and I'm sure you guys don't know what this is, but for people who have are living kind of on the edge, paycheck to paycheck, they oftentimes don't have enough money to get to the end of their week, and they feel that they need to borrow money before their next paycheck. So there are these places that are called payday loan places, and basically what they'll do is they'll give you a loan based on you making the payment out of your next paycheck, okay? And these things, basically, they're going to be in the poorer neighborhoods, and they're going to be preying on people who are less sophisticated and more desperate. and more desperately in need of money. So what happens is, how costly are payday loans? Lenders charge a fee of about $15 to $17 per $100 borrowed. So a typical loan for $350, the fee would be $56. The typical borrower gets paid every 2 weeks, so the loan is for a very short period of time. With the big fee and the short time payment, the APR, so we could go back and we could calculate out the annual percentage rate, is basically going to be over 400%. These loans are just absolutely ridiculous. Anybody that gets involved in these is getting taken advantage of. I understand that there are people that are in really dire straits, and this is the only way out of some things. But this is not much above loan sharking. I guess it's just basically legal loan sharking. So there's a discussion in here about, what would happen if people actually knew how these things were being calculated, and they had a test group that they went through and explained things to people before they took out the loans. Many people still took out the loans because their situations required them to. Some people didn't take out the loans. I guess those were people that didn't have as desperate a need. But you could take a look at that. It's in the book. And it's a very interesting way of looking at things. All right, so let's talk about calculating out the payment for an installment loan. Example in the book: suppose a company borrows $100,000 to be repaid in 5 equal payments at the end of each of the next 5 years. The lender charges 6% on the balance at the beginning of each year. So here's your timeline. You can see that we start at 0, where we get the $100,000 from the loan, and then we have periods 1 through 5 where we've made a payment. Task is to find the amount of the payment, PMT, so that they're all going to be equal. Okay, so we're going to use Excel. Like I said, you can look at the calculation there with the formula if you like, or you can take a look at the inputs that would be necessary in your financial calculator. We, of course, are using Excel. With Excel, you would use the payment function, and we've used the payment function a lot. Okay, so I'm going to stop sharing the book, and I'm going to start sharing my handy dandy little spreadsheet. Now here's my handy dandy little spreadsheet, and I have this listed under calculate payment installment loans. All right, so looking back at the fact situation that they gave us, the rate is 6%, periods 5 years. Payment is what we're trying to calculate, and the present value is $100,000. I put it in as a negative number. So over here, I have calculate the payment. So here is the function, payment, PMT function in Excel. The rate is, of course, going to be that 6%. I'm using B213. Number of periods, B215, 214, 215. Present value is the $100,000, B217. All I do is I hit OK. It comes back with the payment being $23,739.64, which, strangely enough, is exactly what the book says the answer should be. So our formula worked just fine. All right, so now let's talk about an amortization schedule. An amortization schedule, I'll go back to the book for a minute. Okay, so creating an amortization schedule is actually pretty easy to do once you know what all the numbers are supposed to be. Excel makes it an easy thing to do. So let's take a look. Let's see. Each payment consists of 2 parts. Part of it is interest, and part of it is repayment of principal. The interest component is relatively high at the beginning and goes down as the principal goes down in value. So if you take a look at this amortization schedule, you start off with $100,000 that was borrowed. We calculated the payment being $23,739.64. So the interest is charged It's 6% interest. So this $100,000 is the amount that's owed. So the interest is $6,000. The amount of this payment, I guess I can do it over here. The amount of this payment that is principal is going to be the payment minus the interest. So that's going to give us this number here of the $17,739.64. The ending balance is $82,760, which is nothing more than the beginning balance of the principal minus the principal payment, which will give you this. Line 2 for year 2 begins with that number. 82,260 is our beginning principal balance for year 2. We have our same payment of the $23,739. The interest changes. See, it goes from $6,000 to $4,000 because now we're only charging interest on the $82,000, not on the $100,000. So the interest goes down to $49.35. That makes our principal payment go up. See, if our interest payment continues to shrink and our payment itself doesn't change, that means as interest goes down, the amount of the payment that becomes principal payment goes up. Okay, so we're still making the payment of $23,739. $49.35 is our interest. Now $18,804 is principal. We take that off of our beginning balance, so now our principal drops to $63,456, which becomes the beginning number for year 3. Payment remains the same. Interest now drops to $3,800. Principal payment goes up to almost $20,000, $19,932, and our ending balance is now going to be $43,000, which becomes our beginning number here. There's our payment. Interest is charged on the 43, so it goes down to $2,611. The principal payment is well over $20,000. It's $21,128. Ending balance is $22,395. So that our payment is going to remain the same. Our interest is going to be that principal times the 6% to give us this amount. And if you add those two together, you're going to find that it equals the amount of the payment. So when we make this payment, we pay that interest, we pay that principal, it drives the ending balance to 0, and we are done. Okay, now I did some totaling here just to show you. You borrowed $100,000 and you paid $118,698. So that means you had $18,698 in interest. The rest of it was the $100,000 repayment of principal. Okay. Now, the way that you make amortization schedule is you just use some basic mathematical formulas. You have to set it up in chart format. So year, the column will be year, and this could go as far as you want it to go. Beginning balance, the original number here, you'll see that I have that listed as coming from the chart up here, the amount borrowed C223. The payment, I had that from up here when we calculated the payment. So I just put that in as a number. I guess I could have used cell D216. Interest, it's going to be a function of the whatever's in this column here. So this is going to be B228 times the rate of interest, which is B225, 225, excuse me. Now notice that the notation up here for the cell address changed. It's $C, $225. When you use the two $signs like that, what happens is it becomes a number that doesn't float, because we know in Excel, all of our formulas, they float based on the period, the placement of the cell and the placement of the formula. I don't want that to float. I want it to always be this 6%. So that's why that number is locked in position. The principal payment, since we've calculated the interest payment and we know what the payment itself is going to be, this is a simple function of subtracting the $6,000 from the $23,000 payment. So it's 228, C228 minus D228, giving us our principal payment. This is easy enough. We have our beginning balance here, which is going to be B228 minus the principal payment, E228, giving us that. And then to set it up on the next line, all I did was take F228 and move it over here to F2 or B229. And then all I did was I used the copy function from this point down. It copied all of my formulas and it calculated all of these numbers for me. Now this was only 5 payments, so I did a lot of the work. Most of the cells ended up being put in by me, but at least a quarter to a third of them. The rest of them were created just by using the copy function. But that's only because there's 5 payments. What happens if it's a mortgage and your mortgage is over 20 years, 30 years, 40 years? Okay, here's a mortgage here that is over 20 time periods. No, actually, that's not a mortgage. Let's ignore that. Ignore what I just said. So if this was a mortgage, then all that would happen is you would extend this out to however many periods there are in this. If it was a 10-year thing, then you would have years 1 through 10, and all the calculations would still remain the same. Of course, the payment would change, and so all these numbers would change if it was over a 10-year period. But just understand that once you set up your formulas, then you just use your copy function, and Excel will fill in the table for you. So it's an easy thing to do if you need to create an amortization table. Why do we need this table? Because at some point, somebody's going to want to know what interest they paid. This is the big thing here, how much interest was paid, because that's going to probably have some tax effect. The lender has to declare that as income. The borrower may or may not be able to deduct that on their taxes. Okay. All right. So the next thing that the book wants to talk about is a mortgage. So a mortgage is going to be over a much longer period of time. I'll share over into the book again. All right. You buy a house, you take out a 30-year home mortgage. It's a 30-year home mortgage. How many payments are you making? Well, not 30, because you don't make your mortgage payments annually. You make them on a monthly basis. So 30 years times 12 monthly payments is 360 payments. Okay, so you take out a 30-year mortgage, $250,000 with an annual rate of 6%. What is your monthly payment? Okay, so I'm going to go back to my spreadsheet. All right, and I'm going to calculate the monthly payment on this mortgage. Okay, so I set myself up my table that I've been using all along through this entire chapter: rate and per payment, PV type. Here's what my answer is. What was my formula? I used the function for PMT because I'm looking to figure out what the payment needs to be to make this $250,000 payment happen. So notice I had put the 250,000 as a negative number in here. So looking through, rate is B245. Oh, no. The rate, because of the fact that this is a monthly payment, okay, we have a 6% mortgage, right? Our interest rate is 6%. So that means our monthly interest rate is 0.5%, 0.005. I tried to put this in as a percentage and have this be set as a percent. For some reason, it wouldn't work for me, so I needed to go and put in the 0.005. Number of periods is 360. The payment or the present value is a negative $250,000. Okay, now to make that go to the future value of 0, we'll calculate the payment. Everything's into our input sections here, and it comes up with a payment of $1,498.88. which the book says 1,498.87. Since I have mine in currency, the 88, it rounded to the 88 cents. So in the end, we're going to have some pennies we need to deal with on the last payment. I'm not too concerned about that. So we were able to calculate the payment using the payment function, and that's what we wanted to do. The next thing that the book wants us to do is, now if we wanted to go through the trouble of making an amortization table, we would have access to all of the numbers that we're looking for on a monthly basis. It's just that it would be 360 lines long, which is fine. These types of things do happen, and I've made these and given these out to clients many times in my business. So if we had the amortization schedule, and somebody were to say to us, "Oh, what's the principal balance at the end of year 3?" Well, I could just look on the amortization schedule, and oh, there it is. For this loan on the 100,000, it was the 43,000. But on this one here, the book wanted us to go through the process of trying to figure out what the ending balance was after 12 payments. Okay, so now here's my input chart. Rate is still the 0.5% because it's a 6% on a 12-month basis. So there are 12 periods. Okay, so 12 periods. Payment is the 149.88. I picked that up from up here. I put it in as an input. And the present value is the negative $250,000. So now what we need to do is we need to find the future value after 12 months. That's just doing a future value calculation. So when we look, I use the FV function. The rate is that 0.5%. The number of periods is 12. The payment is the $1,498. The present value is the negative $250,000. Hey, Excel, calculate this for me. The ending balance, the principal balance, is $246,929.93. That, if we had an amortization schedule, that's what it would tell us. So that's the way it is. All right, so now let's do some other things that we have to do some thinking to get to the end of. The book wants us to do some other things: total principal payments and interest payments during the first year. Okay, so here's where I calculated out the total principal payments for the first 12 months. And what we have to do is we have to figure out how much of this was interest. Well, the interest is easy to calculate, because if we know that we end up with a principal balance at the end of the 12 months is a $246,929, and we started with 250, it's going to be the 250 minus the 246. That's going to be the $3,070.07. So that is our total principal payment. All right, so what's our interest payment? Well, what are our total payments? Well, we take our total payments, so the $1,498.88 times 12 gives us $17,986.56. We know we had principal payment of $3,070, so let's subtract that out. Our interest payments were $14,916.49. Okay, now total payments over the life of the loan is something that they wanted to ask us. Assuming that we didn't sell the house or pay it off early, we paid it over the 360 payments. We're going to have the $1,498.88 times 360 payments, $539,596.80. Total interest is going to be that number, the $539 minus the original loan of $250,000. We paid interest of $289,596.80. Boy, a lot of money, right? We paid more in interest than we paid in principal. Now, if you don't like that answer, I'm going to go back up to this amortization schedule that I had earlier. Okay. Now, as you see, every time that you make a payment, it changes the amount of principal, right? So when we made this payment, I'm back in this other loan, the $100,000 loan. When we made that first payment, our payment included $17,739 in principal, which brought our balance down to the $82,260, which then became the number that we calculated the interest on for the next payment. Okay. If you don't like this result down here, then what you need to do is you need to change the way that you're paying the principal. Now, the book gives us the example of what happens if we make it a 15-year mortgage as opposed to a 30-year mortgage. Well, we have the loan out for a shorter period of time, so we're going to pay less interest. But because of the fact that we have fewer payments that we're going to make, 15 times 12 is going to be what, 180? So now we have 180 payments. Our monthly payment is going to go up. So our monthly payment isn't going to be $1498.88. Our monthly payment is going to be $2,109.64. So it's going to go up by basically $600, a little over $600. So by making that additional $600 payment, it's going to drive the principal down much quicker. So then we'll get to zero much quicker because the interest and the principal fluctuation between them, the allocation between interest and principal, will start moving much quicker in the favor of the principal of the payments. Okay, so just a piece of advice for you out there. If you can take the 15-year mortgage, take the 15-year mortgage. That's great. If you can't, if you don't want to guarantee making a $2,100 a month payment, you want to only be held to this basically $1,500 a month payment, then take the 30-year loan, but make additional additional principal payments when you can. So if you can make an additional $100, $200, $300 per month principal payment, which generally the bank allows you to do, that will change this blending between the interest and the principal, and it will drive the actual final date that you go to zero. It'll start driving it more, towards closer. It'll make it less far away. You'll pay off the mortgage quicker. And then, realistically, if you had an Excel spreadsheet and you could just change the principal payment, you could show, kind of a column in here for additional principal payments, and then you would end up driving this number down, which would drive that number down, which would drive the interest number down. You would easily move up the final payoff date of your mortgage. Okay. There's a discussion in here about, I'll move over to the book here. We need to talk about this. Adjustable rate mortgages. Adjustable rate mortgages are the type of thing that the amount of your payment will change. The nice thing about locking in a conventional mortgage is that you lock in your payment, okay? You lock in your interest rates, you lock in the amount that you borrowed, and so the amount of your payment is not going to change. Now, in the real world, your payment will also include an escrow to pay your taxes and your insurance. That changes, but that's not the loan. That's the stuff that if you didn't have it as part of your loan, you would be making those payments. And if the insurance company raised the rate, you would grumble, but you'd pay the bill. So when we talk about the payment that is allocated to your principal and interest, it doesn't change if you have a conventional fixed rate mortgage. So it's nice being able to plan around that number. The whole thing about taking out a mortgage on a piece of real estate is that we do live in an environment where the economy does have a built-in factor for inflation. And usually when we talk about investments, inflation is the enemy. Oh my God, we've got to make sure that we invest in such a way that our return is going to be higher than inflation, or we're losing money. True. But when you borrowed money, you borrowed that $250,000 on that mortgage we just talked about. You borrowed that money based on, if you borrowed this year, 2024 dollars, but you're going to be paying it back in 2025, 26, 27, 28. So 30 years on the 20, you're going to be paying it back through 2054. And $2054 are worth a lot less than $2024. So although you're paying a lot of dollars in the future, those dollars have a lot less value. You've received raises. This payment is going to look less and less abusive to you as time moves into the future. Hopefully, you're successful in your career and you're getting raises, and so your pay is going up, and this payment will become less and less difficult to make. So put it that way. Problem with adjustable rate mortgages is that as time goes by, your payment will change based on any changes in the interest rate. So if interest rates go up, your payment will go up to reflect the higher interest factor. If interest rates go down, then yes, your payment will go down to reflect the lower interest rate for that. The other thing that the book talks about is some very strange types of mortgage that were given out as with introductory rates and whatnot. And then many people were allowed to postpone payment of any principal. They would just continue making, and they would actually pay half of the interest until the loan got to 110% of the original amount, and then it would reset a new interest rate and a new payment. Obviously, your payments are going to go up because you've added to the principal by not paying all of the interest over the period of time. And then what was also happening was the interest rates were going up at the time. So people had payments, they would have a $400, $500, $600 mortgage payment that all of a sudden shot up to $2,300, $2,400 based on these deals. And this is one of the things that led to the 2008 2009 crisis in the economy. And so there you go. We'll talk about that. All righty. Auto loans and remaining balance. What I want to do is I want to go to, I think I have it up. Let me see if I do. I have to try and share my screen. Yeah. Okay, this is the toolkit that the publisher gives us. And if we look down, I think you'll be able to see the auto loan stuff down at the bottom here. I don't want to spend a lot of time with auto loans. If you want to get involved in auto loans, then have fun, please do. But the auto loans are basically built to take advantage of you. They have something called the rule of 78. So if you were to add together the months 1 through 12, you would end up getting 78. And so what they end up doing is they end up using percentages of the interest rate using the rule of 78. So basically what happens is they hit you hard with the interest at the beginning of the loan, which, keeping in mind, because of the way that amortization works anyhow, you're making the higher interest, your blend between your interest and principal is the worst it's ever going to be at the very beginning of the loan. And now they're deciding that the interest rate should fluctuate and go down as the year goes by, or as the term of the loan goes by. So they're actually charging you a higher interest rate at the beginning of the loan, and then reducing the interest rate so that it averages out to what they say the rate is actually going to be. It's just abusive in my mind. but hey, you know what? You can get away with it. I guess that's just fine. Okay, back to the book. So understand that there is this thing called the rule of 7 to 8 out there that deals with automobile loans, and you can take a look at that if you want. I don't want to spend a whole lot of time on it. I'm running out of patience with this chapter, and I really want to move on. Okay, annuities. Growing annuities. What? What are you talking about? What the heck's a growing annuity? Well, that's a very good question. Basically, what we've got going on is if you wanted to set up an annuity for yourself and have that annuity be inflation proof, what that means is basically you're going to end up requiring the payments that you take out of the annuity to grow to make sure that that payment stays even with inflation. All right, so let's see here. A prospective retiree wants to determine the maximum constant real or inflation adjusted withdrawals that he or she can make over a specified number of years. Suppose a 65-year-old contemplating entire retirement expects to live 20 years, has $1 million in his retirement account, expects the investment to earn 6% and inflation to be 3%. Wants to withdraw a constant real amount annually over the next 20 years so as to maintain a constant standard of living, basically buying power. If the first withdrawal is to be made today, what is the amount of that initial withdrawal? Oh, annuity due, right? It's another one of the interesting problems here. All right, so set up a spreadsheet model similar to the amortization schedule where the account earns 6% per year, withdrawals at 3%, and then use Excel's goal seek feature to use to find the initial inflation adjusted withdrawal. A zero balance has to be what you achieve at the end of the 20th year. Or use a financial calculator, or use the relatively complicated and obtuse formula. The book is saying that. I'm probably going to stay away. So let's go look at how we make this work using a spreadsheet. All right, so this is the spreadsheet tool that was given to us by the publishers. And this is the example that was just given to us in the book. Number of years is 20. Nominal rate is 6%. Available is to invest is 1 million. Inflation rate is 3%. The initial guess of withdrawal is $50,000. Basically, they took the 1 million and divided by the 20 and came up with the 50,000. Is it going to be at the beginning or at the end of the period? This is going to be at the beginning. So let's set up the amortization table. I'm going to go into, well, let me see if I can go into mine. Yep. All right, it looks exactly like the so all right, so when I set it up using the number of periods being 20, the nominal interest being 6%, the portfolio available for investment of $1 million. Inflation is 3%, the initial guess being $50,000 of withdrawal in the beginning or the end of the period. So I set up the spreadsheet for 20 periods, 20 years. And this is the way that I set it up. I numbered the years, then I had a column for beginning balance. So beginning balance was $1 million. What was my withdrawal? The $50,000 was my initial guess. So that is, you know, if you look at it, it's going to be set to B270. All right, remaining investment. So the $1 million minus the 50,000, because see, the 50,000 is taken out at the beginning of the period. So that 50,000 is gone before we make any of our earnings. So we end up with a remaining investment of 950,000. Then we multiply that by the 6%, and that becomes the $57,000 earnings. That actually gives us earnings or an ending balance bigger than where we started. Now, of course, that number has to come over here. Now, the withdrawal for period 2 has to be 3% higher than the previous year because we want to make sure that we take into account inflation. Okay, so I have this set. The formula is C274, which is this here, times one paren 1 plus the interest factor, and I have the dollar signs in there to make sure that that doesn't move. That's a locked in cell, end paren, and then that'll give me the increase to 51,500, and then each of these payments is 3% higher than the one that just precedes it. Okay, so ultimately we would eventually get to a point where we end up starting to draw down on the principal. But at the end of 20 years, we would still have a value of $731,000 in this account. That's not what we were asked to do. We were asked to drive this to zero. Okay, so what I'm going to do is I am going to do the what was it, best guess feature or something, I can't remember. So what I have to do is I have to hit data. I have to move this bar and what if analysis across the top here. So when I hit the what if analysis, it's going to ask me, what do I want? Scenario manager, goal seek, or data table? Goal seek is what the book suggested that we use. So I'm going to hit goal seek, and it gives me a window that pops up. So what I want to do is I want to set cell, this one here. I know what this cell needs to be for this to work out. This cell needs to be 0. Okay, so I'm going to set cell, what is that? A, B, C, D, E, F293, okay? And it's putting it in with the dollar signs so it doesn't move. How much do I want that to be set to? Well, I want that to be set to 0. By changing cell, which cell do I want to change? This one here, the initial guess. And I hit OK. And now it calculates it out for me as 64,786.87 and some change there. That we'll have to eventually deal with getting that to dollars and cents. But as you notice, what happens is we end up drawing down the principal every year. Under that other time when we had the 50,000, we actually went up for a few years. But now we're drawing it down every year. So $1 million less than 64,786 gives us 935. It gives us earnings of 56,000, which drives us back up to 991, which comes over here. We withdraw the 66, 924 is left. We hit 55 additional, which gives us 980. And so our withdrawal, our annuity amount is growing by 3% every year. And then our remaining investment continues to drop. Our earnings continue to drop. Our ending balance continues to drop until we eventually get to 0. Our last payment is going to be when we get to 113, and the end of year 19, it's going to be $113,604 left in the account, which will become our beginning balance in year 20. And since our payment happens at the beginning of the year, we take all of that out, which leaves us 0 to invest, 0 income, and that leaves us a 0 balance. So we've driven this exactly where we want it to be by using the goal seek function that Excel gives us access to. So this is a neat way of doing this. And this is a growing annuity, a constant growth annuity. All right. Another example is suppose you need to accumulate $100,000 in 10 years. You plan to make a deposit in the bank now at time 0, and then make 9 more deposits at the beginning of each of the following 9 years. Hey, what is that? That's an annuity due, isn't it? And then make 9 more payments at a total of 10 deposits. The bank pays 6% interest. You expect inflation to be 2% per year. You plan to increase your annual deposits as at the inflation rate. How much must you deposit initially? First, calculate the real rate, which is going to be the 6% return. Inflation is 2%, so it's 106 over 102. Then we're just going to subtract 1 so that we take it down into a decimal. So it's going to be 0.0392157. We're not actually getting 6%. We're getting a little less than 4%. Okay. Now, because inflation is expected to be 2% per year, in 10 years, a target of 10,000 will have a real value of $82,034.83. And then I'm just going to use the book's toolkit. I didn't bother doing this on my annuity. Tables. Oh, this one here was if it was at the end, it would just change everything because the earnings would go up because we had the earnings for every year before we took the amount out. So remember, we had the $64,000 in the one up here. If it was at the end, it would go up to $68,000 by delaying that first payment. All right. All right, so this is the problem. We have 10 years. We want to gather together $100,000. We have 6% discount rate. We have 2% of inflation, and we're going to do everything at the beginning of the period. So here's our chart, period 0 through 10. Payments, compound value. We still need to calculate out this payment. Okay, so here's our interest rate. Constant dollar figure target. So future value would be the nominal value. We're looking for a future value of $82,000, but that's the present value of 100,000, I believe. So if we end up doing it as a present value, we would end up using our future value and our rate. So 6,598.87 would be the amount that we would be required to put in. And then ultimately it would become $100,000 as time went on. Okay, so this is its value after 10 years. This is its value after 9 years, 7 years, 6 years, blah, blah, blah. So, all right. I believe we made it to the end of the chapter. Yay. Okay, so I'm gonna stop sharing because everybody's getting tired of looking at spreadsheets. So I'm sure one of the things that I did was I went through and I tidied up the Cengage Mind Tap, not Mind Trap, it's Mind Tap. But I did go through and I tidied it up. So now all of the homework assignments that are due for each of the chapters have been reset as far as their due dates. Okay, so one of the things that I had done was said that I wanted to have and I'm going to bring up the syllabus real quick. Because of the fact that we had some problems here at the beginning of the semester. Some of this might not actually be perfect, but all right. So when we get back to school on Tuesday, it will be March 19th, right here on the syllabus. Okay. So we'll have covered chapters 3 and 4. We did not begin chapter 5. So I'm not going to worry about that at the moment. Okay, so chapter 3, we did have Seth and Matt do the mini case, and they did wonderfully. The mini case for chapter 4 is supposed to be Casey and Jordan, and hopefully the two of you have been able to get together and start working on the mini case for this chapter 4. And this is the Tuesday, or this was the Tuesday class that was on a video, and this is the current video that you're watching now, the March 14th class. All right, now, March 19th is next Tuesday. There are homework questions for chapter 3 and for chapter 4 that are supposed to be done. I have set the due dates for chapters 3 and 4 homework assignments for next Monday at midnight. So you have all day Monday to do it. So today, tomorrow, wherever you're listening to this, you've got until Monday, March 19th at 1 minute before midnight to do homework for chapters 3 and 4. You pick that up right off of Moodle. You can go through and do them. Okay. Now, chapter 5, we haven't done chapter 5 yet, and we're going to have the mini case with, I have it with May and Jordan. I guess that's right, May and Jordan. So the two of you will have the mini case for chapter 5 that will be due at the beginning of class next Tuesday. Then the homework for chapter 5 will be due by midnight on Tuesday. Okay, so a lot of work here at the beginning of next week, but that's us getting caught up because I was having some trouble with getting the Cengage stuff set up. So everything is set up and I believe in perfect shape right now. So on Tuesday, we will get caught up with chapter 5. The mini case, chapter 4 mini case is going to be done on the 19th. The chapter 5 mini case is going to be done on the 19th. And then I'll go through and do the rest of the chapter. And then the homework will be due at midnight next Tuesday on the 19th. Thursday, we're going to watch the movie, The Big Short, and we have a 3-hour class. It's under 2-hour movie, so we're going to have a lot of time to do discussion about what we saw in the movie. Then the next class will be the following Tuesday, March 26th. That's my brother's birthday. We will have our first exam, and that will be on chapters 1, 3, 4, 5, and what we discussed in the Big Short movie. The paper that is going to be due from the Big Short, we can make it due, let's make it due the 28th. So I don't want to do the same day as the test, so we'll make it due the class after the test. So then we'll be back on schedule and everything will be perfect on Thursday the 28th. We'll have chapter 7, corporate valuation, stock valuation, and I want all of you to work together on the mini case. Okay, so that's something that needs to be put together so that it's available and presented at the beginning of class. That means you'll all be very prepared for that class. So you can see what the schedule is. We'll be sticking with that schedule. So everything should work out pretty well. I just need to make sure, Matt, if I had changed this properly to make sure, because I know you had given me a date you weren't going to be in class. I may have to change one of these assignments, but we'll talk on Tuesday about that. So everything else should work well as far as how we have this going. This was chapter 4 was a long chapter, and it was a lot of work. All of it is done in Excel, though. So the spreadsheets do all of the work for us. We didn't have to sit down and do any massive formulas ourselves. We just had to know how to create the various charts and input tables that we needed to use for the input into the functions in Excel. So I think everything we're on track exactly where I wanted to be. I'm going to send everybody an email. So before you'll have seen this, you'll have seen the email. So I don't know why I talk about the emails I'm sending out that you've already received. That's kind of the weird thing about doing things backwards in time. So, all right, that's it. We will be in class on in the classroom on next Tuesday, the 19th. So we'll see you then. Bye-bye.